Alright, so then from Monday, I'll come around and I'll collect the test that I handed back, and then if you would do this warm-up problem, finding the domain, the vertical asymptotes, asymptote behavior, and end behavior. Side note, it's going to be beneficial for you to have your extra note sheet that we started on Monday out along with you, okay, so that you have that. We'll add to that today also. And make sure you have that, so because you can use that on all of your formatives and your summatives and your tests and your final and all that fun stuff. Okay. So, first thing we gotta do is we gotta find the domain. According to my supplemental note sheet, my extra sheet, how do I go about doing step number 1? Set the denominator equal to 0. Okay, all right. So then that would be x minus 3 equals 0. Right? Okay. So that's going to give me x equals 3. Okay. So what would then my domain be? So all real numbers except x cannot equal 3. Right? Okay. So all real numbers, x cannot equal 3. Okay. What would my vertical asymptote be then? X equals 3. Would be my point of discontinuity, so I have a vertical asymptote there. Okay? All right? Then it said we had to describe our asymptote behavior. So that's going to be an AB. So as x approaches 3 from the left, what is our function doing? And as x approaches 3 from the right, what is our function doing? Both of those are going to be infinities, right? Because it's going to either make a turn, it's going to get close to that vertical asymptote, and it's either going to have to turn up or turn down. Okay? So we said then, let's pick a number close to 3 on the left side of 3. Can we get even closer? 2.9, okay? So the left side, so 3 minus, we're going to plug in 2.9. If I plug in 2.9 into my function, 2.9 minus 3 is what? Negative 0.1, right? Okay. A negative divided by a negative. That's positive, right? So that one is going to go to positive infinity. Hold on, let me move this over a little bit so we have Then we need to try a number on the right side of 3, but close to it. 3.1. Negative 1 over 3.1 minus 3. 3.1 minus 3 is 0.1. So we have a negative divided by a positive. That's going to be negative, right? So then this one goes to negative infinity. Then we said we've got to get our end behavior. That's going to be as x goes to positive infinity, what's my function going to? And as x goes to negative infinity, what's my function going to? Okay. So we need a really, really big number. I don't know. 1,000? Pretty big. Okay. All right. So then we'd have negative 1 over 1,000 minus 3. So that's going to be negative 1 over 997. Positive or negative? Negative. Okay. So that's going to approach, but it's going to be super duper small, right? That would approach 0 from below. Then we go out to negative infinity. So let's say negative 1,000. What can you tell me about negative 1 divided by negative 1,003? It's positive, so it would approach 0 from above. Remember with y is above. Yeah. I know, that's always been the trickiest part of this, because in this line up here, it means left and right, but in this line, it means up, above, and below. It's all depending on what it's on. And that's the answers that we needed, right? Questions on that? All right, let's do another one here now. Find me the domain at just the vertical asymptote. You don't have to find me the end and the asymptote behavior, just the domain and the vertical asymptotes. So I need to put my denominator equal to 0. Now, I can solve this one of two different ways. Okay? One way is I could factor this. And I get two answers. Difference of perfect squares, factors out, get it. Okay? Another way that I could do this is I could add 9 to both sides. And then I could take the square root of both sides. But if I take the square root and I'm solving, plus or minus automatically comes into play. Okay? So, my domain is all real numbers, but x cannot be plus or minus 3. Okay? If you write out positive 3 and negative 3 there, totally fine. Actually kind of like that more because of the next step that I'm going to say. My vertical asymptotes are x equals 3 and x equals negative 3. There, because those are two separate lines, there you can't use the plus or minus. Okay? You got to write those out separate. Okay? Good on that. All right. That being said, you do this one now. Find me domain, vertical asymptotes, asymptote behavior, and end behavior. Agree with my domain. Yeah. Yeah. Agree with my vertical asymptotes. Oh, many. Because we've got 2 vertical asymptotes, that means we have 4 asymptotal behaviors. We got to go left and right side of each one. Okay? So let's go -5 first. So I want to be left side of -5. That's going to be -5.1-ish. Okay? So then that's going to be -5.1 over something a little bit bigger than 25, right? Right? Because 5 squared is 25. 5.1 squared would be a little bit bigger than 25. And I subtract 25, that's going to be positive. Right? Okay? So this is going to be a negative divided by a positive is going to be negative. OCD's kicking in. If I go right side of -5, that would be like -4.9. If I plug that in, now I've got -4.9 divided by something that's a little, when I square -4.9, it's going to be a little smaller than 25. Right? Did anybody square 4.9? Would be like 24.8-ish. Okay? Alright? So then that minus 25 is going to be negative. A negative divided by a negative is a positive. So that one's going to be positive infinity. Don't need to actually calculate all these numbers, as long as you know your number sets. Now let's go to +5. Left side of +5 is positive 4.9. So now I would have positive 4.9 divided by, again, a number smaller. Here, this number would be smaller than 25. So that would be a negative number there. So then this is going to be negative infinity. If I go right side of +5, that'd be like positive 5.1. Now I have positive 5.1 divided by a number bigger than 25 minus 25 is going to be positive. So then that becomes positive. Now if I check my end behavior, if I go with a big number, like let's say 1,000, I would have 1,000 over a really big positive number, right? Because 1,000 squared is going to be 1,000,000. minus 25 is 999,975. So that's going to go to 0 from above. If I go out to negative 1,000 now for my negative infinity, now I'm going to have negative 1,000 over 1,000,000 minus 25. That's still going to be positive, which now that then would be negative. So this would approach 0 from below. Questions on any of that? I'm waiting for a question, since you didn't write any of it down. So on Friday's formative, you're just going to send me a picture? Because you're going to have to do all of this writing on a test, on a quiz, on your homework, right? Yeah. Too bad I'm going to go to the next slide. Should have taken that picture, shouldn't have you? Yeah. Okay? So our next step is now we're going to talk about our horizontal asymptote. Okay? So let's talk about what a horizontal asymptote is. So first off, just like a vertical asymptote, it is a line. Okay? So a vertical asymptote has the form x equals some number. What does the horizontal line have a form of? Y equals some number. Okay? So it's going to look like always y equals some number. Now, this horizontal asymptote is going to be extremely important for you because it will come into play in end behavior. So far, our end behaviors have always gone to 0. Okay? Well, now, what our horizontal asymptote does is it shifts our graph up or down. And so now this end behavior number that we're going to be approaching either from above or below now becomes our horizontal asymptote number. Okay? So with vertical asymptotes, we can have as many as we want, right? As long as wherever the denominator is equal to 0, that we can have as many as we want. Okay? With horizontal asymptotes, you can either have 1 or none. You can't have more than 1. You don't always have to have 1. We'll get into that later on in the chapter. But if you do have 1, you only get 1. Okay? You can't have multiple horizontal asymptotes. All right? So, here's how we figure out a horizontal asymptote. Okay? We compare the degree. Now, help me one more time. What is the degree of a function? The what? Can we be even more specific? Because it's not always written in standard form. The biggest exponent. So remember that degree. Whoa, what's going on there? The degree is the biggest exponent. Okay? So we're going to compare degrees of the numerator and the denominator. So we're going to look at the biggest exponent on the top, and we're going to compare it to the biggest exponent on the bottom. Now, when you're comparing two numbers, you only got three choices, right? So my first choice would be that the top is bigger than the bottom. I think I went there, yep. If the top number is bigger than the bottom, there is no horizontal asymptote. What's another choice for comparing degrees? Comparing two numbers. Top number bigger. What's another possibility? Top number smaller. Okay. So my bottom number is bigger. Then my horizontal asymptote is the line y equals 0, which is the x-axis. That's what you've been dealing with up to this point. Okay? You've always had a larger degreed polynomial on the bottom. You just have to notice. Okay? What's my third choice when I'm comparing two numbers? They're equal to each other. Okay? And if they're equal to each other, then the horizontal asymptote is the line y equals a over b. Now, where do you get a from and where do you get b from? Great question. Those two are the lead coefficients. Okay. So if we write it in standard form, it'd be the very first number on the top over the very first number on the bottom. Okay? Grab out your supplemental note sheet. Let's fill it, or add to it, I should say. Okay? So this is now back on your supplemental note sheet. So you should already have a space reserved for step number 0, because we're not there yet. You should have a space for, come on. Yeah, because you weren't here on Monday. Yeah. Did you watch the video on Monday? Yeah. Probably want to go watch that. Yeah. Then you will know all about this. Okay? We have a space reserved for step number 1. Then, right below that, now we're going to go step number 2. And step number 2 is going to say we need to find the horizontal asymptotes if possible. Okay? So your choices are, remember, you're looking at degrees here. If it's big over small, it's a none. If it's small over big, your horizontal asymptote is y equals 0. If it's the same, then your horizontal asymptote is y equals a over b. And again, we get a from the lead coefficient, and we get b from the lead coefficient. Give you a moment to get that down. Okay, so then put that supplemental note sheet off to the side again so that we can get back into some notes. So, what I would like us to do now is I want us to just find the horizontal and vertical asymptotes and the domain of these two functions. Okay? So, first off, we can probably do the domain of this first one right in our head, right? Okay? What's the domain of this first one? I like it. Which means, what's the vertical asymptote? X equals -1. We just take the can't equals part out. We got that. Right? Okay? Now, and let's see, Again, this is where having that supplemental sheet out with you helps out. Okay? What is the degree on the numerator? So the top, what's the degree up top? The degree up top is 2. What's the degree on the bottom? 1. Okay, because there is an x, so it's a 1. Are we bigger on top, or are we bigger on the bottom, or are we the same? Bigger on top. Our cheat sheet says we have none horizontal asymptotes. What do you got? Give me a domain on the next one. All real numbers. Yep. Okay. Which should automatically flow into. Yep. So and we split them up. Okay. Degree on the top for this one. Degree on the top. 2. Degree on the bottom. 2. Is that bigger, smaller, or same? That's the same. So then what do we have to look at? The lead coefficients, right? What's the lead coefficient on the top? 6. What's the lead coefficient on the bottom? 1. Okay? So my horizontal asymptote would then be what? Y equals 6, or y equals 6 over 1, which we can just write as 6. Okay? I think this is the last. This is the last. Yes. Okay? So for this function, 4x over x minus 2 quantity cubed, find me domain, horizontal asymptote, vertical asymptote, end behavior, asymptote behavior. Find it all. Go. Everybody agree with me so far? We got a domain of all real numbers, but x cannot be positive 2, which means that vertical asymptote at 2. I have a degree on the top of 1. I have a degree on the bottom of 3. Because the x is inside the parentheses that has an exponent of 3. So it, therefore, has an exponent of 3. So it's a 1 over 3, which is a small over big, which means y equals 0 is my horizontal axis. Everybody agree with me on that so far? Okay. Then let's check. So we got to be on the left side of 2. So let's go 1.9. So I'd have 4 times 1.9, which is going to be 7.6, but it's going to be positive, all over 1.9 minus 2 cubed. This right here is going to be negative, correct? Negative cubed is negative cubed is still negative. Okay? Positive divided by a negative is negative. So that's like the negative infinity. Let's try right side. Let's go with 2.1. 4 times 2.1 is going to be 8.4, which is going to be positive. 2.1 minus 2, then cube. So this now is going to be positive. A positive cube is positive. Positive divided by a positive is positive. So this is going to be positive infinity. Try a big number. I'm going to have 4 times 1,000. That's going to be positive. I'm going to have 1,000 minus 2, which is 998, and I'm going to cube that. Is that going to be positive or is that going to be negative? That's going to be positive. Positive divided by a positive is positive. So we're going to be approaching 0 from above. If I go with negative 1,000, now I've got 4 times negative 1,000, which is going to be negative, all over negative 1,002 cubed. That's going to be negative. Negative divided by a negative is a positive. So this one is also going to approach 0 from above. Okay. You now have enough information to get through, to get through number 3 on this week's homework. Okay? So you should be able to do 1, 2, and 3